So you have this. The reason why there are 5 formulas on the front page is because there are 5 different ways that givens can be presented in these questions. So there's always going to be a formula that matches what you're trying to solve for. We're supposed to go through the derivation of these formulas. So I'm not supposed to start off accelerated motion just giving you a list of the formulas like this. But we have to save some time in this online structure. So things like that I know really don't have to do with whether you will understand how to do the work or not. I thought maybe we'd save till the very, very end. Like in first year university, they may expect you to know where these formulas come from. So if we get time in the last couple of days, there's a few things that maybe we'll circle back to. But for now, I'm just going to give you this chart. So these are the 5 acceleration formulas. You don't have to memorize these formulas in grade 11. You're always going to have a formula sheet. And actually, because you're at home and you're not in a regular school format anyway, you're always going to have things like this in your notes. So there, the formulas are right there. If you look at these 5 formulas right now and ignore the setup of the formulas and the fractions and the brackets, if you just look at the variables, they're all the same. There's distances, there's times, there are 2 different speeds, V1 and V2, and there's the letter A. But each one of these 5 formulas is missing something. And that's on purpose so that you have 5 different formulas that will solve anything that you need to solve. So actually, if you look at example 1, and we'll flip back to the front page in a minute, the way that traditionally, the way that acceleration has been taught in school, the way I was taught it even in grade 11 was, this is the one point, maybe your math teachers have done this already. They ask us to suggest to you now that you make what's called a givens list. In other words, make a list of what's in the question, because that's the best way to figure out how to do the question. And your givens list can only have a possibility of 5 things in it: V1, V2, A, D, and T. These are the 5 variables that are involved in accelerated motion. And every time you do a question, no matter what the question is, you're always going to have an unknown. And often that's the easiest thing to search for, is to just read the question and say, okay, what is my unknown? You're driving on the QEW 100 kilometers an hour, you accelerate forward. What distance will your car travel? So D is the unknown. That's what we need to solve for. And then your goal is to fill in 3 other numbers in this list. And in this question, you can see that there are 3 numbers. So they're all there. You just have to make sure that you identify what they are, though. See, there's the trick. You have to read the question and make sense of sort of the English structure of the language so that you can write the right numbers down next to the correct variable. Because if you misidentify a number, you're going to pick the wrong formula. So let's go through this. Just start at the beginning. You're driving down the QEW at 100 kilometers an hour. So that's the starting speed. Nothing's happened yet. So 100 kilometers an hour. Next, you decide to accelerate forward at 2 meters a second squared. Well, that's the acceleration value. 2 meters per second squared. And if you flip to the front page for a second, below the chart, it says a word about the units on acceleration right here. Let's go there for a second with this on the board. Acceleration is, like, the definition of acceleration is, it's telling you how fast your speed is going to change every second. So think about it. It's not a speed. It's like, how much faster are you going to get every second? So what this is saying, or the units on acceleration, you'll have some kind of speed, like say 2 meters a second, but that's per second. So in effect, it's saying you're going to get faster 2 meters a second. You're going to get 2 meters a second faster every second. Well, these units are very difficult to type. Meters per second per second. It's sort of strange. What do you could write it like this, I suppose, meters per second, but it still kind of looks weird. So the chosen way that, the chosen format that has been written is meters per second squared, meaning seconds times seconds. These meters per second over second, the seconds do not cancel out. The one on top is in a denominator and the one on the bottom would be in a numerator. It would be over 1. They don't cancel. So the short form is to have them multiplied together. So it's very important to indicate that this little 2, that's not a math operation. That's actually, it's on the bottom of, it's not this. It's not meters per second squared. It's, the squared is here, just written on the S as a little short form to say that there's actually 2 S's there. Is this going to affect anything? Is it going to affect whether you get right answers or not? No. In fact, I mean, at this point, especially in grade 11, you can just kind of fall back on the idea that when you see the units, meters per second squared, you know right away that it's an acceleration unit. And that's not a math operation, so you won't be squaring anything. All right, back to this question again. Flip back to the other page. And I should mention, you're going to be confused here. You're not going to get this until we go through a few examples. Don't worry. I mean, I was really stressed when I learned this the first time, and here I am teaching it now. This isn't enough to pick a formula. You have to have a third number. So something else must be given, and it is. It says, what distance will your car travel if you accelerate for 5 seconds? Be careful, just because the word accelerate is mentioned in that sentence doesn't mean that 5 seconds is an acceleration value. 5 seconds is still a time. 5 seconds. So in the list of variables, there's always going to be an unknown. There's always going to be 3 other numbers in that list. And there's always going to be something that just isn't even part of that particular question. There's always a variable that's not mentioned, and you don't have to find it. Just the final speed, it has nothing to do with this particular question. And that's how you pick your formula. You don't pick your formula with what the unknown is. You pick your formula by what's not even in the question whatsoever. So if you flip back to the front page, that's why there's 5 formulas. Because there's always, the wording of a question always has something that's just not in the question at all. And I know these formulas look totally different from one another, but there actually is a sensible way that you get the formulas. I just don't want to go through it given the time constraints that we have. But each of these formulas, if you strip through the clutter of looking at all these letters and math operations, they're each missing something. I would put this up on the screen, but it's going to take too long. If you look at the very first formula, and this is why I put a little chart beside it, so you could quickly put like a little X for what's missing. If you look at the very first formula in that list and cut through the rhetoric of different things, there's no V2 in that formula. So do this. Sorry, this is a lot easier than putting it up on the LCD projector. Very first formula, the second column. There's no final speed in that formula whatsoever. If you look at the next formula, D equals V2T minus 1/2 AT squared. It doesn't have a V1. That's the formula that you use if the starting speed is not mentioned. The next formula, it's an acceleration formula. It's not a constant speed formula, but it doesn't have the variable A in the formula. So each of these formulas is missing something. And then similarly, the next formula has no distance, and the next formula has no time in it. So it kind of looks like this. I should have put them in order diagonally, but that's okay. These are the way the formulas are usually written. The university doesn't let you use anything like this. You're supposed to look at these 5 formulas and just know from using them enough in high school which of the formulas, which formula is missing which variable. But this is where it gets easy. I mean, to jump in advance a little bit here, you're going to pick one of these 5 formulas to do a question, and that's it. And then you're going to substitute into the formula, the same as you did with constant speed, And it's just going to be order of operations to get the answer. So it looks hard at first, especially with the physical look of these 5 formulas, but you've done all this math before. There's nothing in here that you haven't seen. It's just typical bed mass. So this question here on the board, example number 1, there's no V2 in the question whatsoever. So if you go through the list of formulas, by coincidence, it's the very first one. That's the formula we're going to use. But there's one caution before you get there. You have to get used to, and you hopefully already have, with the work we did already, you have to get used to converting units before you get to a calculation. And you don't want to forget. So it's always best to do it while you're using your givens list. Like without even going any further, I would change this right away. 100 kilometers an hour is not going to work with these other units in the list. It's got to be in meters per second. So punch that into a calculator, divide by 3.6. I'll skip the details because it's on the board. You're going to get 27.7, and it just keeps repeating. And I don't want to lose that. I don't want to lose all those 7s because it might actually affect the answer. So that's why I'm putting that line there, or a dot. I guess I should have put a dot. So these are the numbers we're going to use. And as long as you identified your variables in the right spot, as long as you didn't misidentify what one of these given numbers was, you'll pick the right formula. And then once you pick the right formula, if things are converted and they're already in standard metric units, then the work that follows is actually pretty easy. You pick your formula, you write it down, and this is one of the reasons why you always have to write a general formula. It's not just for organization, but you have to show what you're even doing. So write down the formula and then substitute in your variables, and be careful, be neat, use lots of brackets and things like that. I know there's no brackets in the formula, but V1T beside each other without a sign in the middle, that's whenever you have things beside each other, the assumption is that you're multiplying. But now I'm going to write some numbers for these, so I'm going to use a set of brackets just to separate it. I'm going to do this. I'm going to write everything in 2 sets of brackets, so I keep that plus sign away from everything else. This is all multiplication, and this is all multiplication. So V1, the V1 is 27.7. I'm going to, on the board, just because I want you to be able to see this and I want to write a little bit bigger, I'm not going to put units in this formula because I'm doing it on the board. You're supposed to have units on every variable in a formula. 27.7 meters per second, and then you would multiply by time. Time is 5. So that's that set of brackets. And then this one over here, 1/2 is 1/2. That's not a variable. That's actually a number that's in the formula. So I'm still going to leave it as 1/2, or you could write it as 0.5 if you like that better. Multiplied by A. So the A value is 2. And it's not 2 squared. The meters per second squared, those are the units. So it's just 2. And then you multiply by the time, and it's only the time that's squared in this formula. This exponent of 2 is not like this entire term. It's just the t. So I'm going to have to write 5 squared. That's all you have to show. And actually, I didn't show enough. I should have had units in there. You can show more lines of work if you need to, especially if you need to just for yourself, even for like a study note to show yourself how you got the work. But there are no marks for anything else but the final answer. So it's up to you. I've lost my calculator here, buried in all this course stuff. But I mean, for something like this 27.7, it's a repeating 7. So make sure you're using it as a repeating 7. You don't want to limit yourself till you get to the very end. Where did the 27.7 come from? So that I'm subbing it in for V1. And if you look up here, sorry, there's a little bit too much on the board right now. So V1 was 100, but the 100 was kilometers an hour. So it had to be converted to meters per second. And to do that, you divide by 3.6. So back to this, I'm just going to continue. And you really should do this. Don't try and just copy this off the board and move on. You want to make sure you can do this and get the same answer as me. So you get 163.8, and the 8 just keeps on repeating. That's distance, that's in meters. And you would never leave it with that many decimals. Maybe I'm just going to write 164 meters. And then you think about it. Don't forget that very last step with any physics question is, don't just leave it as an answer. Think about what the situation was and think about whether it makes any sense. So if you're going down the highway at 100 kilometers an hour and you step on the gas pedal for 5 seconds, that seems completely right. 164 meters is totally sensible. Let's say you made a math error somewhere along the way and you got 16.4 meters. That's kind of what I mean when I say you might not know that your answer is correct, but if you make mistakes, you'll often know that it's wrong because you get some answer that's just preposterous for the situation involved. We're going to do lots of practice on this. This is what today is for. In the regular semester, we don't do accelerated motion formulas in one lesson. It takes a couple of lessons. So let's do some more examples so you come to a point where you realize this is actually easy. It's not going to seem easy yet, but it is. It's really easy once you get into it. And you're in grade 11 now. So one thing you're going to find is, and you may not know this yet because you haven't really started doing it, you're going to find that you're making less math mistakes than you were last year. Your brain is a little bit more mature in terms of stuff like that. And I don't know what to say about it. Just every single year in school, you get better and better at doing things that you made mistakes on in the previous year. And you're not even really learning anything new necessarily. You're just better at it. You guys ever go back and read an essay that you wrote in grade 9? Some of you are really good writers and you know you are, but if you go back and read an essay you wrote in grade 9, you're going to cringe at how bad the grammar is compared to what you know now. Let's do example 2. So without even reading it, the very first thing you should do on any question now is write a givens list. Like set yourself up for the fact that you know that you have to identify variables and it's always the same 5. So I would write out a givens list blank and fill it in as you're reading the question. Sometimes it's easier that way. All right, an automobile traveling 56 kilometers an hour. Here we go again. More unit conversions. That's V1. 56 kilometers an hour is the starting speed. Is 24 meters from a barrier when the driver slams the brakes on. So it immediately starts decelerating, and it doesn't stop because it says the car hits the barrier 2 seconds later. If the car stopped, it wouldn't have hit it. So the car was traveling some speed when it reached the concrete barrier. That's what this question is. How fast was the car traveling upon impact? So 56 kilometers an hour, that's starting speed. V2 is the unknown in this question. And this is what we're going to solve for. And you can tell already what the answer is going to be. It's going to be somewhere between 56 and 0. It can't be 0 or the car wouldn't have hit. And it can't be greater than 56 because you're slamming the brakes on. It's just going to get slower and slower and slower. The distance in this question is 24 meters. And the time is 2 seconds. So this question doesn't mention any rate of deceleration. It doesn't tell you how quickly the car's speed changes when you step on the brake. It just doesn't mention A at all. But it's still a deceleration question. It's not a constant speed question. You're still slamming the brakes on. So you still need an acceleration formula. You just need the acceleration formula that doesn't mention variable A because you don't know anything about A. So you flip to your formula sheet. You go through these little X's if you really need to, but hopefully over the course of the next year or two, you won't need these X's, and you just look for the one that has no acceleration in it. And you write the formula down. So D equals V2 plus V1 divided by 2 times T. Well, here's where you run into the next complication. So each one of these examples has a little bit of a complication over the last one. So, I mean, you're typically going to get formula sheets, and formula sheets, they can't put every different version of every different formula isolated for every variable, because instead of having 5 formulas on a page, we'd have 15 or more. No, we'd have 4 different rearrangements of every formula. There'd be 20 formulas on the page. You never get that. They give you the standard formula the way it's just written kind of universally around the world. And if you're not solving for what that formula is already isolated for, then you have to isolate for other variables. Now, here's where I run into a problem with grade 11s, and especially this year, because of what I was saying about your grade 10 math courses. I don't know how adequately grade 10 was taught to you. And even in, like, before any of this COVID nonsense started, the one math skill that has always been lacking the most in grade 11 is not bedmass and order of operations. The skill lacking the most is rearranging formulas. So here's that formula you have to solve for V2. You're solving for how fast the car was traveling upon impact. You have 2 choices here. You can rearrange that formula for V2, and ultimately that's what you need to do before you leave high school. You need to be a really, really good formula rearranger. You want to just glance at a formula, and if you're not solving for what it's isolated for, you just very quickly whip everything around and isolate it for something else. But I know from experience as a grade 11 physics teacher that a lot of you would make math mistakes right there on the rearrangement. You won't make math mistakes on the substitution. You'll just rearrange the formula wrong. And this isn't a math class, it's a physics class. So I don't want to see you make math errors on every rearrangement of a formula, because that's not what you're here to learn in this class. So you have to kind of make a personal decision. You're eventually going to have to isolate formulas every time. And grade 12 is going to mandate that. But if you find that every single question you try and isolate the formula, you get a math mistake and you're doing it wrong, in grade 11, you can leave it however it's written and just start subbing values in and see what happens. A lot of times, once you put the values in, things cancel out or add together, and it becomes a little bit easier to isolate. So let's do that. We're just going to sub the values in, but I've forgotten something that's very important, and I shouldn't even have gotten to this point where I wrote the formula down before I converted this. Because then the ball starts rolling and you start thinking about other stuff, and you forget and use 56, and you end up getting it wrong. So 56 kilometers an hour is not standard metric units. I have to divide that by 3.6. It's 15.5, repeating, meters per second. I have to use that instead, or else the question won't work out. So if you sub these numbers in without isolating, let's see, D is 24. So 24 meters equals, V2 is the unknown, so we don't know that. V2 plus V1. V1's 15.5 repeating, divided by 2 times time. And time is, by coincidence, 2 seconds. So, I mean, you can see in this question, by sticking numbers in first before isolating, if that's not your strong point, you've got 2 on the bottom and a 2 on top in this question. They cancel each other out. And by canceling each other out, there actually won't even be a fraction there, because you're taking the denominator off this fraction by canceling it, and then there isn't even a fraction. And if there's no fraction, the brackets aren't even really that important here. So now it becomes a much easier isolation, because you're subbing numbers in first and working it out a little bit. Now it's obvious to just bring this to the other side. It's plus on this side, it'll become negative over here, and your final speed will be 24 meters a second oh, sorry, 24 meters minus 15.5 repeating. So what's that on a calculator? 24 minus 15.5. So you get a final speed of 8.4 meters per second repeating. I don't know if that's right, but if you think about it, it's at least not wrong. Like, it's not ridiculous. Your answer can't be greater than 15 because that's the speed you're starting at. You can't get to 0 because if you got to 0, it would never hit the wall. So there could be a math error here, but 8.4 isn't preposterous. And that's always what you should check.
Why do you put that? Oh, I think you're about to ask the same question.
Oh, that's okay. What's that?
Oh, never mind. I thought somebody else was talking and it was just my voice echoing.
Yeah.
Why do you put the line over the 4 and a dot over the 5? Like,
No reason. Bad habits. You're supposed to put a dot if it's just like you're writing one number and you want to say that it's repeating.
Oh, okay.
If there's two numbers, let's say it was 15.53 and you want to show that that repeats, let's say it's 53, 53, 53, 53, then you're not supposed to put a dot, you're supposed to put a line.
Oh, okay.
Or two. I just stupidly flip-flop back and forth without thinking about it. They both mean the same thing. But that's a great question. So if every question is just identify the variables and pick a formula and isolate the formula if you need to isolate it, how does this get any harder? Well, let's look at example 3. Typical situation. You're dropping something off a high height. So you drop a penny off the Skyline Tower, and the question here is, how long is it going to be in the air? How long will it take the penny to hit the ground? It's not a constant speed question because if you drop something, we have gravity. So it's going to accelerate all the way to the ground. I'm going to push this up into the corner as far as I can go here to get more room. Given, it's okay. All right, so if you read a question and you have no idea how to do it, the very first thing you should do is, because they all start the same way, make that Givens list. Make a Givens list and just convince yourself that there has to be a way to put 3 numbers in this list. That's your goal. As soon as you get 3 numerical values, the rest is just order of operations. And there has to be an unknown. So I always start by reading the last sentence and just identify what it is. How long, time-wise? So how much time is it going to take? What is this question? Sorry, I was just fooling around. I thought I changed it, but I guess I didn't. It was dropping a penny off the Skyline Tower, but yeah. Bored on a Saturday. Is that what yours says? You decide to go for a leisurely leap? Yeah, okay. Well, whether it's a penny or not, same thing. We're going to solve for time. How long does it take any object, regardless of what it is, to fall from the Skyline Tower? So you read the question and you have to identify 3 other numbers. And there's no numbers. So what the heck do you do? Well, number one, this wouldn't be on a test or a quiz because you can look up some values. This would be on an assignment. So if you ever do a question and you don't think there's enough information given, don't be afraid, especially if it's like a real world object like the Skyline Tower. The whole point of the question would be that there might be some information that you have to quickly look up. So we need the height of the Skyline Tower. You could jump to internet and look it up, but I already know what it is. I'm doing this question too many times. The observation deck is 142 meters. But that's not given in the question. We would have looked that up on internet. But what else? Because you can't do the calculation unless you can get 3 numbers. And there's 3 more spaces. So 2 of these other 3 numbers, there must be something that you can fill in. And this is where not every question is just blatantly giving you the numbers, because sometimes there's things that after doing this enough, there are values that you should know. So first of all, after today, after this example, free fall acceleration on Earth, if you're not stepping on the gas or you're not dragging something to a rest, if you're just dropping something, the acceleration is always the same. That acceleration is based on the planet itself, the density of our planet, the gravitational field. So this is a number that you're allowed to know. The acceleration on Earth is 9.8. And that's a very famous number. From this point forward, you're going to use that number for years. 9.8 meters per second squared. If you jump, you will speed up 9.8 meters per second faster every second that you fall. So that leaves two other possibilities, and we have to know one of these. So which one? And what's the number? You either know the starting speed or you know the ending speed. Any suggestions? Well, 0 is a number. So in this question, if you're up top at the Skyline Tower and you step off, your beginning speed is 0. And you're allowed to say that. This is a number. And it's actually a very common number in acceleration formulas to use 0 for something. So you start off with no speed and you just get faster and faster and faster. So at no point in this question do we need the final speed, because it doesn't ask for that and it doesn't give it. So once you get over that hump and you got 3 numbers in the question, you check the units, make sure that they're not centimeters or kilometers or minutes or anything like that. Make sure it's all standard. And then that's it. You can flip to the front page and pick the formula. Be careful. Don't pick the formula that has an X for your unknown. Like, don't pick the formula that doesn't have time in it, because then you wouldn't be able to solve for time. You want to pick the formula that doesn't have this in it, the variable that's just not even mentioned at all, V2. So if you scroll through the list, the formula that has no V2 in it whatsoever is the first one, again, by coincidence. So we have this. D equals V1T plus 1/2 AT squared. And again, if you don't like the way that's written, you can think about it like this. Think about it as 2 sets of brackets with a plus sign in the middle. So sub in your values. V1 is 0 meters a second, and normally you would multiply that by time. Or sorry, you can't multiply by time because we're solving for time. 0 times t, that's actually just 0. 0 times anything is 0, so it completely wipes out that part of the equation. And you would add that to 1/2 multiplied by A. Your A for free fall is 9.8 meters per second squared, and multiply that by time, and time is the only thing that gets squared. And I can't sub in for it because that's what we're solving for. I forgot. T squared. It's the other side of the equation that has the substitution I should have put in. The distance, 142 meters. Okay, that looks a little bit messy. Let me clean that up a little bit. First of all, 0 times t is just gone. We don't even need that in there. And so that means that plus sign isn't really necessary either. We can just focus on this. And the brackets, you could leave them on there, but they're not even necessary right now either. So we have to solve for time. I should have isolated for t, I guess, in the beginning, but that's okay. Just do what you can do. Do what you can do to make it easy to isolate. The 142 on the left, I'll leave that there. 1/2 times 9.8 times t, I might as well do that. 1/2 times 9.8 is 4.9 t squared. And so just keep isolating for time. Take as many lines as you need to get the answer. Just remember, they're not worth marks. So if you bring the 4.9 over, it's multiplication on this side. It would be division. and you get your final answer, 142 divided by 4.9. You get your final answer of 28.98. Right? Wrong. Well, I mean, it's right, but again, think about common sense. If you're dropping something off the Skyline Tower, it's not going to take 29 seconds to hit the ground. Can you imagine? Just start timing that on a stopwatch right now. Okay, ready? Go. 1, 2, 3. Just imagine you're falling. Okay, we're at 5 seconds. Okay, you're falling, 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 falling. Now we're at 10 seconds. You're still falling. No, this is still t squared. I moved the 4.9 over, did the division, but this is still t squared. So one more thing you'd have to do, take the root to get a final answer for t. And an answer that would make sense at this point, 28.98, take the root of that, and you get a real answer, 5.4 seconds. Now it makes sense. But that's, again, a perfect example of how sometimes you'll get answers and you'll forget to do something, and just by looking at the answer, you'll know something's wrong with it. So what else? How can this get any more complicated than this? Well, let's do one final example, example number 4. I wonder how long I can record for. I'm just thinking of the file size on this thing, but that's okay. Let's see what happens here. So example number 4, although we live in a metric system, we have the United States right next door to us. And you actually are kind of inundated with American culture. And you do see non-metric units quite a bit. Like, for example, calories in weight loss programs. There's no metric unit called calorie. Our metric unit for energy is called a joule. You've probably never even heard of it. Feet per second. If you go and buy a paintball gun right now at Walmart, as some of you likely have, the rating for the speed is always in feet per second. That's just, I don't know, most of the gun manufacturers are in the States, and they rate how quickly the guns shoot in feet per second. It won't happen on tests and quizzes, but on assignments, you'll occasionally get units that are imperial units because you have to learn to deal with them. We're surrounded by them. So let's do this question. Your paintball gun. So you're shooting something straight up in the air. If you're shooting a gun up in the air at 300 feet per second, how high is it going to go? The bullet, or in this case, the paintball. Be careful not to say that if you're shooting something off the ground, it's going to start with 0 speed because it's on the ground. That's impossible. If it started with 0 speed, it would never rise. It would never be going up. So no, the starting speed can't be 0. The starting speed has to be what the velocity of the gun is, 300 feet per second. But that's a really common mistake, is to say that the speed on the ground must be 0 because you're standing there. Pretend this is the gun. You're standing there and you haven't shot it yet. Well, of course, everything's 0 when you haven't begun. But as soon as you pull that trigger and the bullet leaves the gun, it's traveling upwards at 300 feet in 1 second. I'm going to stop right there before even doing the rest of the question, because that has to be converted or we can't use it. I'm going to convert it the same way as I did yesterday. If you ever encounter a unit conversion that you don't know what to do with it, think about this in your head. Think about multiplication of ratios. And actually, this one's only going to take 1. But you always think about multiplying by ratios, and you think about canceling out the word. So you can absolutely convert this to whatever you want, as long as you cancel out the word feet, or I guess foot, with a relationship. So you jump online or you jump wherever you need to go, and you look up a relationship between, like, how many feet are in a meter, or how many meters are in a foot, whatever you want to look up. And I know the value because I've been doing this enough. It's 3.2. If you looked it up online, there's 3.2 feet in 1 meter. Cancel the word feet or foot, and you don't even have to ask yourself whether you multiply or divide because it'll be right there in front of you, telling you what you have to do. So 300 divided by 3.2. We are instead going to use 93.75 meters per second. I'm going to need some board space here, so I'm going to erase all this and just write this value over here. 93.75. If this feels like it's too many things now and it's starting to feel hard and you're getting anxious about it, this is not a question that would be on a test or a quiz. I just wanted to put an American conversion on there for the sake of it. Okay, you need to fill in this list. You need to identify what you're looking for. How high will it go? That's distance. And you need 3 numbers on here or else it's not going to work. The initial speed is given, 300 feet per second, and then converted. So what else can you fill in? Because you have to get 3 numbers. If you don't have 3 numerical values, you can't pick a formula and you can't calculate. So you must either know the final speed, the acceleration, or the time it's going to be in the air. Any suggestions? Just turn your speaker on and say it. No? Well, the reason this is going to go to its highest point, because that's what we're looking for, is it's going to lose all of its speed. So as it goes up, it's going to get slower and slower and slower and slower, but if it still has speed, it's going to go higher. When it eventually gets to its highest point, the reason that it's going to be there is because the final speed will be 0. And you don't have to be told that. That's by reading the question and making sense of it, and by practicing these questions, of course. You'll come to the realization when you can use zeros. So the other thing in this question is, a bullet from a gun is not a little rocket ship. It doesn't have a little fiery tail that's pushing it upwards. It's basically just this. It's just, throw something up in the air. It's an object that is traveling upwards, but gravity's affecting it. So once again, the acceleration, although it doesn't feel right at first, but yes, the acceleration is Earth's gravitational pull, 9.8 meters per second squared. But it doesn't get 9.8 meters per second. It doesn't get faster 9.8 meters per second every second. It gets slower. So you have to watch when you're doing acceleration questions. Whenever you write down an acceleration value, you always have to ask yourself, is it speeding up or is it slowing down? Most of the questions are speeding up. But if it's slowing down, you have to use a negative sign. You have to put a negative on it to mean that it's actually, there's no such thing as deceleration in math and science. There's only acceleration. The problem is in the English language, we use acceleration for getting faster and deceleration for getting slower. But there actually is no scientific word deceleration. There's just positive and negative acceleration. So if something's slowing down, you have to use a negative and they won't tell you to do it. So there's no time. So you flip to the formula sheet and look for the formula that has no time in it. It'll be the very last one. And write that formula out. And you can do 2 things. You can either isolate for what you're looking for, or if you're a little bit worried that your isolation is going to be math errors all the time, you can sub things in and see what you can do with it first. And just be careful. Just make sure you put the right variables in the right spot. So V2 is 0. Actually, I'm not even going to show that. I'm just going to write it as 0. V2 is 0. V1, and you have to square it. V1 is 93.75. So that has to be squared. And then there's a 2 in the formula that isn't part of this Gibbons list. So it's 2 multiplied by A. Now be careful here because there's a negative sign. I don't know how I'm going to show this. Maybe I'll just put another set of brackets in here. I'm going to multiply by negative 9.8. And I want to make sure I deal with that sign correctly. And then multiply by distance, but distance is the unknown in this question. So what can you do here? Well, I'll leave the left-hand side alone. 0 is 0. I'll square the 93.75 just to get that done. 8,789.0. I'll keep 2 decimal places, 0.6. Might as well do this. 2 times negative 9.8. That's going to be negative, I forget, what is that? 9.8 times 2. Negative 19.6. And then it's still multiplication with D. Okay, so we have to solve for D. There's a negative sign, there's a 0 on the left. You can't do anything with this. You can't break up 2 things that are multiplied together until you get rid of everything else. So I would have to take this to the other side. The sign on it will change. It'll become negative 8789.06. And you can't have negative answers. So here's where that negative sign on the A value is going to help. Because now when you isolate for D, this is multiplication despite the negative sign being out the front. Think about it like this. So we're going to take this, it's multiplication, move that to the other side, it'll become division, but the sign doesn't change. It just goes on the bottom. So you've actually got 2 negative signs on the left, and they cancel each other out and give you a positive answer, which is what you have to have anyway, because you can't have negative answers for distance. If any of you actually do use, say, paintball guns, and you're looking at this thinking, wait a minute, this isn't a common sense answer. 484 meters up in the air, that's almost half a kilometer. We're not counting wind resistance, which we wouldn't be able to do in grade 11 anyway. That would complicate the formulas in ways that you can't deal with yet. So that's a common sense answer. If there wasn't any wind resistance whatsoever, it would go that high.
Do we have to like, oh my god, I'm zoning out. What if there is sorry, I just lost my train of thought.
Oh, that's okay. I see. I'm not the only one.
Oh, what if we isolate it first? Do we have to show all the steps, or do we just show the first line?
No, absolutely not. In fact, I mean, that's what you want to work towards. It's just early. And like I said, you're in a class that's very there's a lot of different math levels in our class, I think. I mean, ultimately, the goal that you want to work up to is looking at that very first line and being able to just quickly say, I'm looking for distance, so it's going to be V2 squared minus V1 squared divided by 2A. University is going to make you do that. They're not going to let you fool around with all these little steps. They're going to say, isolate the formula first so that you just sub into it one time and you get your answer. So they're going to want you to show that you're going to do 0 squared minus 93.75 squared, and you're going to divide it by 2 times A, 2 times negative 9.8. And then you get the same answer. And in fact, not only do you get the same answer, you get a much more exact answer because you don't go fooling around with little part step lines where you're slowly putting things together. You'll just hold the calculator one time and you'll do the work and get a more precise answer. In this case, it doesn't make much of a difference. Still 448.42, a little bit more specific. But that's, I mean, when you isolate first, you always get more specific answers. But like I said.
Oh, sorry.
No, go ahead.
Do we have to write units in the question?
Oh, yeah, technically you do. Just on the board here, I know there's not a lot of room. I don't want you to lose that habit because, like I said, university is going to make you show units in the formula so that you can work them out. I mean, in this class, if you have a givens list, and you have to have a givens list with units shown, the units have to be somewhere. You have to show in your solution that you thought about and considered the units. So if you want to put them in the givens list and then not put them in the formula when you're working it out, that's fine, because I'll look at it and say, yes, you considered the units. But I mean, somewhere along the way, you got to make a note to yourself saying that's not going to be good enough when you get out of high school. And I know I don't want to keep talking about university. It's 2 years away, but it's kind of like when you, I don't know, when you first start learning to drive, if you make some sloppy little habit in the beginning, it's hard to shake it later on when you get used to it. And this is one.
So like, do I have to put in every single line or just like the first line?
Just the first line, just the substitution line.
Because like once you start multiplying, it gets weird.
Yeah, it does get weird. You wouldn't know exactly what to write. Yeah, and that, again, remember, they only look at 3 lines. They only look at your formula, your subline, and your answer. So if you're not, I mean, really quite clear on this yet, don't worry. We're doing this, we're going slow. This is too important of a topic to be hurrying through. We're going to try some practice questions. There's 6 of them on the page here. I was bored, so I was writing out as stupid of questions as I could think of for some of these. The answers are on here in bold, but as usual, I'm not going to leave them as just these answers in bold. They're there so you can check them when you get an answer on your calculator and see if you're right. But I'm going to put up the full solution so you can go through them line by line as well. This is all we're going to work on. It's already, yeah, it's already 20 after 11. We're going on lunch at 11:30, so don't even look at this yet. We'll go on lunch. We'll come back. We'll start session 3 by working on these, because I don't want you to do these on your own. I want to have the microphone open so you can ask as many questions as you can. And it would be the same in real class. Not that this isn't a real class, but you know what I mean. Students don't sit here for 75 minutes and go through a couple of examples and then go home with 6 practice questions, because if you start doing the first one wrong, you're going to do them all wrong. I always say to people at the end of this lesson, go home, don't think about this, come in tomorrow, and we're going to have a work period where everyone in the class is working on these 6 questions so that you can help each other out and ask me questions. Well, unfortunately, I don't know if you guys can help each other out. I hope you can. I hope there's a way that you can quickly connect with each other. Like I said, if there's 2 or 3 people on the list that you know, I actually encourage you guys, I don't know, I encourage you guys to try and make connections even with people in this list that you don't know. The only way that I survived first year university was working with other people. And the problem is right now, what you're doing right now with this forum and the list of people at the side of the screen, that's what my son is seeing right now at Trent University in the forensics program. So he's like you, he's a virtual learner, and there's like 43 people in his class, but he doesn't know any of them because he's never met them before. And he doesn't want to just randomly send messages saying, hey, can we work on the assignment together? But I said to him, you have to. You got to figure out some way of just breaking through that ice and just randomly trying to connect with some people to get a work group together, because you have no alternative. And physics, science in general, I mean, we stress collaboration. If you went into science, you're never going to be a scientist working by yourself. There's always going to be a team. You always run your values by other people. You always get peer editing. You always collaborate. We're just in the difficult position in high school where we can't have you collaborate on everything because every single person would have a 95. So we still have to have tests where you're individually tested, unfortunately. But once you get out of school and you're into the real world, there's no such thing as individual testing anymore. You're always going to be working with other people. And that's why the assignments in this class are not, like, even if it was a regular class, all the assignments in this class are all take-home assignments where I encourage you to work with each other. Okay, well, so we're going to cut this off 5 minutes early. Why not? I need to stop this video anyway, or I'm going to fill the entire hard drive. So we're going to work on questions when you get back. And I'm going to stop this recording right now.